Good day to you all. Welcome to this video channel where I'll be explaining about the concepts of embedded systems uh, chapter wise. We'll be following this book called ARM Assembly Language Programming and Architecture by Muhammad Ali Mazidi. And this is just an introductory video. So let's just see what it is, right? First, we have to learn what's microprocessor and microcontrollers, right? As you can see in the diagram, this is a diagram of a general purpose microprocessor, right? Where you can see the CPUs in the left hand side, followed by the RAM, ROM, IO port or input output port, timer, interrupt, and serial communication ports, right? And they're all connected to each other through a bus, right? And as you can see, all of these units are independent. They are not dependent or they are not, integrated together. They communicate together through the bus, but they are not integrated as a singular unit. They're all different units. So they must be connected externally, right? And on the other hand, where you have microcontrollers, where the CPU, RAM, ROM, input-output port, timer, interrupt, and serial COM port, as well as including the bus, are all connected together in a singular unit. That's called a microcontroller. So see, what it facilitates is you do not have to externally, connect different peripherals along with the CPU. Everything is included inside one chip. So it's easier to program and it's easier to integrate in any small devices where you don't need an entire CPU to process. And examples will include washing machines, say air conditioners, uh, small TVs, right? Where you don't need the entire CPU to perform your job because the device has limited capabilities, right? Such as your washing machine, you can set your timers, you can set what kind of temperature you want to control, what kind of fabric you are going to use, this, that is the spin speed and all. Only that much. It's the limited applications. In such devices, we are going to use microcontrollers so that it's easier, it's cheaper, and far more efficient, or you know better utilization of the resources that we have at hand. So the microcontrollers are also known as a system on chip or SoC. It's quite a famous name. The other name is MCU or microcontroller unit, right? Okay, let's see through some of the history and some of the other details about ARM. ARM has defined the details of architecture, registers, instruction set, memory map, and timing of the ARM CPU and holds the copyright to it. The various design houses and semiconductor manufacturers license this intellectual property for the CPU and can add their own peripheral as they please. So it is up to the licensee. There is the design houses and semiconductor manufacturer to define the details of peripherals such as input output ports, serial port, UART, timer, ADC, SPI, DAC, I2C, and so on. So all these peripherals that just I just mentioned, we'll see this in the coming videos. Don't worry, we'll explain and go through each one of them. So as a result, while the CPU instruction and architecture are same across all ARM chips made by different vendors, the peripherals are not compatible. See, an AC that is manufactured by Samsung, uh, the parts required for that may not be compatible with the parts required for an AC manufactured by, say, Toshiba or someone else, right? They use the ARM architecture internally, but the peripherals that are connected, that differs from companies to company, right? So let's go through a brief history of the microcontroller. In 1980s and 1990s, Intel and Motorola dominated the field of microprocessor and microcontrollers. In the late 1990s, the ARM microcontroller started to challenge the dominance of Intel and Motorola in the 32-bit market. So 32-bit microcontrollers, examples include x86, PIC32, Coldfire, PowerPC, right? So Intel had all this, major um, 32-bit chip market. But ARM came along knocking. So some of the important factors in choosing a microcontroller chip are the clock speed, power consumption, price, and on-chip memory and peripherals, as well as um, microcon the IDE compiler, legacy software, and multiple source of production. Are Those are things that need to be seen before you choose a microcontroller, right? The two main factors in choosing a microcontroller are the chip characteristics. This first, what I mentioned, is called chip characteristics. And the second one are called um, Second ones are available resources. There is IDE compiler, legacy software, and multiple sources of production. Right. So, anyways, that's self-explanatory. A brief history of the ARM. Acorn Computers in United Kingdom in the 1980s, Professor Steve Ferber and Sophie Wilson defined the ARM architecture in instruction. The VLSI Technology Corp was formed in 1985 for Acorn Computers. Apple Corp got interested in using ARM chips for the PDA, that is the personal digital assistant products. So this renewed interest in the chip led to the creation of a new company called ARM Advanced RISC Machine. RISC is short for Reduced Instruction Set Computer, and its other cousin or the other side of the coin is CISC, that is Complex Instruction Set Computer. So whatever uh, methodologies or the architectures that we are going to see are associated with RISC, RISC. And as we can see in this diagram, this is an ARM simplified BOG diagram where, as marked, the portion designed by the manufacturers and the portion designed by ARM. If you see the blue rectangle that's marked as ARM core, that is the ARM microcontroller, right? It has its own RAM, ROM, and all these things. The other portions, that is the system, analog, memory, serial interface, and other peripherals, those can be manufactured by anyone, any other company which holds the intellectual property uh, to, make those changes. So they would have to pay some amount and they have to buy that IP, right? And on the right hand side, it shows the simple ARM ARM microcontroller structure. Just an example. We'll see these things in details in the coming videos. And a simplified ARM core data flow model is shown here. Don't worry. Again, the diagram should be self-explanatory, where data comes in on the top. They enter or they are stored in register from R0 to R15, total 16 registers, and then they flow to the MAC and the ALU, and they are processed. And after that, they come back to the register, and from the register, they can move back to any peripheral device that you connect it to. Again, we'll see these things in the coming videos. Some of the famous companies that use this ARM microcontroller architecture, many famous companies are included here, such as Texas Instruments, Samsung, Toshiba, Fujitsu, right? Atmel, Actel, Broadcom. Okay, first things first, let's say the ARM architecture. The ARM supports byte, half word, and word. Byte is 8 bits, a half word is 16 bit, and a word is 32-bit data types. Right? ARM supports them all actually. It's clearly shown in the diagram how it works. So this is just an introductory class, and we'll see the other details and concepts in the coming classes. So I apologize in advance for the audio quality. I do not have a noise room to cancel it out. Please like and subscribe this channel. I'll see you in the coming videos.